Hi guys, welcome back. We're going to start our lesson on 20.2, which is talking about the shape, center, and spread of data. And we're also going to talk about how to do some of these computations using your graphing calculator or using the statistics calculator that I posted on Google Classroom. So the essential question is going to be which measures of center and spread are appropriate for a normal distribution and which are appropriate for a skewed distribution. So we're going to talk about what these distributions are and how we compute center and spread and which ones are appropriate for the different shapes. So most of the time we're just given raw data, which is just usually presented in some type of unorganized list. And we like to organize the data by using the frequency in which they occur. All right. A lot of times we're going to be using a line plot, which is almost like a histogram with little X's marking each time an event happens. And that will give us the shape of the distribution. So once we have the line plot, we'd look at the shape of the line plot, and then we can describe the shape of it. So here we have a table of raw data. Okay, so 20 babies are born, and this is some information about those 20 babies. We have the birth month. All right, so birth month 1 would be January. Birth month 3 would be March, and so on. Then we have the birth weight of each baby in kilograms, and then we have the age of the mother. All right, and as we scroll down, it just lists off the 20 pieces of data. It just re-puts this here so you don't forget the name of the categories. All right, so those are the 20 pieces of data. So the first one wants you to find the line plot that represents the distribution of birth months. Okay, so you don't actually have to do the whole line plot. You just need to identify which one it would be. So obviously the answer is here, but how would we identify the answer? So what I would normally do is pick a value where there's 3 different answers. So month 12, here there are 0 babies born in month 12, here there's 2 babies born in month 12, and here there's 1 baby born in month 12, which in our case would be December. So if you go back and look at your raw data, we would see here 1 baby was born in month 12, and if I scroll up, 2 babies were born in month 12, and that would be it. So when you're looking at your multiple choice options, we would pick the one that has 2 in month 12. So this one would be the correct answer. And this is what we call a uniform distribution because there's no mounds, right? There's no peaks to the data. It's just pretty much straight across. So that would be called a uniform distribution. The next one we're going to do is identify the line plot for the birth weight. All right. So again, let's look at these and the answers marked, but this is what I would do is I would pick a value that has 3 different answers, like 3.8. Here, 1 baby was born at a weight of 3.8 kilograms. Here's 0 babies, and here's 2 babies. So we'd go back to our raw data and see which one it is. So if I look at my raw data, 3.8, here's 1 baby. See if we have any other 3.8s here. Here we go. There's 2 babies. We scroll up. There's no other, so we would pick the graph that has the 2, which was right here. And this one has a single mound with even tails on both sides, so this is what we would call a normal distribution. And then the last one we would identify is the distribution for the ages of the mothers. So again, I would pick a value that has 3 different answers, such as 38 years old. Here, 1 baby had a mother that was 38 years old. 0 babies had a mother that was 38 years old, and here 2 babies. So if I go up to my raw data, 38 years old, as I scroll through all the data, here's 1 mother was 38, and if I scroll up, 0. So 1 was our total. All right, so there was no other ones besides that one. So we would go with the graph that has 1x at 38. And this data, because there's a mound, but the tail on this end is longer than the other tail, the tails are not symmetric, that would be called a skewed piece of data. All right. So the shape of the distribution for the birth months would be a uniform. The shape of the distribution of the birth weights was normal. And the shape of the distribution for the mother's ages was skewed. So let's just break this down. So the distribution whose shape is basically level, that is, looks like a rectangle or even a straight line across, that's what we call a uniform distribution. And this is one we don't really compute a lot of statistics about because any possibility is pretty much equally likely. There's not one that's more likely than the other. Okay, the likeliness that you're born in December is not necessarily more likely than when you're going to be born in May. Where the next one is a normal distribution, where you have the mound in the middle and the tails are equal. All right, that would be considered a normal distribution. It looks like a bell shape. And then one that's mounded, but the tails are not symmetric. You have a longer tail. That's called a skewed distribution. When the longer tail's on the left, that's skewed left. When the longer tail's on the right, that's skewed right. So these are the three shapes of those. Like we said, uniform would just almost look like a horizontal line because all the outcomes are equally likely, where symmetric is our normal. Here's skewed left because the tail, the long end's on the left. It's not where the mound is, it's where the tail is. And this one would be skewed right. So now let's talk about the parts of the data. All right. So identifying center and spread. So some of the things that we've already talked about before, how to compute them, is the mean is the average. So it's the sum of all the data items divided by how many there are. And again, the calculator, the statistics calculator, is going to compute most of these values for us. The next value is the median, which is the middle value. All right. If n is odd, it's the item that's exactly in the middle. If the number of data items is even, you would average the two middle values. Then we have the standard deviation, which is done by long computations, but there's two types of standard deviations the calculator will give you, and we'll talk about which one we're going to use. And then we have our interquartile range, which is Q3 and Q1 are the medians of the upper half and the lower half. So the difference between them is the interquartile range. And then there's different notations for mean. There's mu and there's x bar, different between the sample standard deviation and the population standard deviation. Okay, so we're going to compute some of the statistics for the same data that we were already looking at. So if you have a graphing calculator, a TI, you can do this under stat edit to bring you to list 1, list 2, and then you can go to stat calc, one variable stats, L1, L2 to compute those as well. If not, you can use the calculator that I posted on Google Classroom, and we can just enter the data into that. So that's what I did for the birth weights and for the mother's ages. So the stats calculator, okay, it's in the stream on your Google Classroom. And here is the list of data for the birth weights. Over here, I just opened up a new tab and we did the list of the mother's ages. Okay, so now that we have all that data stored in those calculators, let's go here and see what they want us to compute. So this is computed on the calculator. So we have our mean, our standard deviation, and our median. So on this calculator, there's just a couple things that are a little different. So I calculate statistics. So the mean, we get 3.6. So we go back. Mean is 3.6. We're just going to drag that here. Now, the standard deviation, the R of X. So we have to be careful because the calculator, all right, here I can see it's going to be 0.14 for either one. But this one only gave us the sample standard deviation. So if you wanted to find the other standard deviation, which is the one you're going to have to find on the homework, what you can do is you're going to take this value right here that says sum of squares, all right, whatever value falls here, 0.42. You're going to divide it by the number of data items and then take the square root. So if you don't have a calculator that does this, if you go up to the top corner here, you can hit Scientific Calculator, right-click it, and open it up into a new tab. And it will give you a scientific calculator here. So we can do our computations. So we said we're going to do the square root of the 0.42 divided by 20. Oops, we had an extra thing there. Okay, and then that will give us the 0.1449, all right, which was the exact same value that the calculator gave here, 0.1449. Okay, but then we're just rounding it to two decimal places, so 0.14, we'll put there. The median value, which when you scroll down on your calculator, it gives you here, but even on ours, the median value was 3.6. So that's 3.6. The IQR, so the calculator will give you the Q3 and the Q1, but it doesn't give you the IQR, so you actually have to subtract them. Here, they actually do give you the IQR, the interquartile range, which is 0.2. So let's go back. And I'm going to put our 0.2 in here. And then we can check to make sure everything's good, and we're correct. All right. So you can get the statistics on, like I said, on your graphing calculator, or you can use the calculator here to do that. Okay. So now let's go for the mother's ages. So for here, the mother's ages, this is the calculator version. But if I go to my meta calculator that we did here, so this was our mother's ages, I'm going to hit the calculate statistics. And we have our mean is 31.8. Okay, so I'm going to go back and put my 31.8 in, which is the mean. Now, again, the sample standard deviation, so the 2.33, all right, that's the sample. We don't want to use the sample one. We want to use the sigma here, but my calculator doesn't give me that. It only gave me the 2.33. So remember, you're going to take the sum of squares, divide by how many there are, and take the square root. All right, so if I go back to my scientific calculator here, I can clear it. And we're going to do the square root. Actually, what did that say? 103.2. So we're going to do the square root of 103.2 divided by 20. Shut the parentheses. And that gives us our value, 2.2715, which is what the calculator said, 2.2715. So 2.27 is 2.3 if we round it up. Median value is 31. Same thing here, median value is 31. Put our 31 over there, and then our interquartile range. So again, Q3 minus Q1 is going to be 3. But if you're on the meta calculator, it will give you that same value. All right, the interquartile range is 3. And we can check our answer, see if everything's good. Yep. Okay, so if we look at our reflection questions, it says, what do you notice about the mean and median for the symmetric data, which was the baby weights, as compared to the mean and median with the skewed distribution? All right, explain why this happens. So up here, the mean and the median were equal. So for our normal distribution, our symmetric distribution, mean and median are pretty much the same, where for skewed data, the mean and the median are not the same. And that's because when you have skewed data, you tend to have one or two values that fall either really high or really low, and that pulls the average one way. So the mean and the median don't end up equaling the same value like they do with a normal. All right. So that's that question. So the standard deviation IQR for the skewed distribution are significantly greater than the corresponding statistics for the symmetric. Explain why this happens. All right, so when we look at our values here, so IQR was 3 for the skewed. IQR was only 2 because, again, if you have a symmetric data, a lot of the data items should fall pretty close to the center, where when you have skewed data, all right, data falls farther from the centers. All right, so that's why those values are more. Okay, so let's just talk about which types of data we would use for each. We're not going to do the histograms because the calculator just does that, and we're not going to have you do that. Right? But the distribution has a single mound and symmetric tails. So what kind of distribution that would be? That would be a normal distribution. Single mound, symmetric tails. All right, that's your normal. All right, and then we would talk about each one. Oh, so I think that's all we're going to do for our lesson. So just something to talk about. So when you have a normal distribution for your center, all right, you're going to use the mean. And for the spread, you're going to use standard deviation. If you have skewed data, for the center, you're going to use the median. And for the spread, you're going to use the IQR. Okay. So there are 3 problems for you to do on my HRW. They have some parts to it, okay, but make sure you're using this meta calculator to do your statistics and to get all the values that they're asking you for. All right, you should be fine. So again, there's only 3 questions, but use this calculator. Also, if you have questions, you can ask me, you can message me for anything like that. Also, I have office hours tomorrow from 1 to 2. All right, if you need to pop into the Google Hangout for my office hours, you can do that as well. Okay, so that assignment will be due on Wednesday, all right, by 2:30, okay? So like I said, message me if you have any questions. You can watch this video and go over it if you need to, but make sure you use that meta calculator on Google Classroom, okay?